Okay, so right now we are going to work on Voltaic cells, which is my favorite thing of the entire year. Um, a Voltaic cell is also sometimes called a galvanic cell. And essentially what happens here is that we have, I'm going to erase this just so I have the maximum amount of space here. We will have two half cells that are essentially just beakers. And inside these beakers, we will have a different metal in each. So let's imagine that we are working with zinc and copper, which is one of the most common combinations that we'll have here. I will have a chunk of zinc metal. That would be an electrode, just a chunk of metal inside this thing. And then right here, we would have copper. So this zinc is going to be floating in a zinc solution. This is usually something very soluble, like a nitrate. So let's just say that this is zinc 2 nitrate. So that'd be NO3 with a little 2 there. And then this copper would be sitting in a solution of copper 2 nitrate. These metals don't have to have the same oxidation number. It's just what happens in this case. So we would attach these electrodes with a wire, and sometimes there will be a voltmeter in here, and that'll just give us the reading of basically how much electrical charge is happening in this system. So in order to get an electric current, I need to have electrons moving across this wire. Now, if you were to look at these two metals in particular, more on that in the activity series video, but in this case we would look at this as a reaction. The half reaction for zinc would be that we have zinc atoms becoming zinc ions. So if you look here, you should know that in order to balance this in terms of charge, I would put my 2 electrons here. +2 and -2 in total gives me an overall charge of 0 to match the 0 that's over here, and then I have 1 zinc on each side. So in this case, our zinc is the one that is being oxidized because it is losing electrons. That means specifically this zinc electrode is going to be the anode. The anode is the specific electrode where oxidation takes place. Now, on the converse, we have copper over here. We would have copper +2 ions absorbing 2 electrons and becoming copper atoms. So in order for that to happen, this means that copper is gaining electrons, and this would be reduction. If this is reduction, that makes copper the cathode. Now, our electrons are going to go from the loser to the gainer. So they're going to go from anode to cathode. So our electrons are going to leave zinc, travel across the wire, and be absorbed by copper. Now, our flow is from left to right in this case. We could have written it the other way. It's not always left to right. Now, as the zinc is giving away electrons, the zinc overall is going to become positive. And as the copper is gaining electrons, it is going to overall become negative. Now, when this happens, the zinc is no longer able to get rid of electrons because these electrons are attracted to this positive charge. So, there is a solution to this. The solution is a salt bridge. Salt bridge usually looks something like this. It's a U tube because it's U-shaped. There'll be some type of semi-permeable plugs at the end of this, meaning some solution can get in and out. Cotton balls is actually one of the more common things. And in this, we would have something super soluble, probably something like sodium nitrate. So, as this zinc is losing electrons and becoming positive, the nitrate ions, which are the negative ions here, are going to migrate through this tube and eliminate this positive charge. And as this is becoming negative, the sodiums which are positive, are going to travel through this tube and fix that overall negative charge. Now, lifetime of the battery. We have zinc atoms giving away electrons and becoming zinc ions. Zinc ions can only exist in solution. So, like I said, these were floating in a solution before. This is actually floating in here. So in this solution is a bunch of zinc plus 2 already. These zinc plus 2s are going to dissolve in this solution. So over time, these atoms becoming ions, the ions dissolve. This is literally going to dissolve and wither away over time. That's why batteries don't last forever. On the opposite end, over here at the cathode, we have copper atoms absorbing electrons. Well, this atom can't absorb electrons because the metal would then take a negative charge, which it will never do. So the solution to that is that in this solution, we have copper plus 2 floating around in here. Because remember, nitrates are always soluble with no exceptions. So as these electrons are coming across across the wire, and they're hitting this copper metal, these copper plus 2s that are swimming around are going to be attracted to those incoming electrons. They absorb the electrons and become copper atoms. The copper atoms are going to stick to the cathode. So over time, this is actually going to grow bigger and fatter. So the anode is going to shrink over time and lose mass. The cathode is going to grow over time and gain mass. Because as these electrons are coming over, the copper in this solution is going to undissolve and stick to the cathode. That is the basics of how a voltaic cell works. One of the most difficult concepts in high school chemistry. If you can understand this the first time around, I would absolutely say that you're a superstar. Most people have to watch this 2 or 3 times before it really sticks. So if you have any questions, let me know, leave them in the comments. I will do my absolute best to get back to you.